We will dedicate this lesson to the main effects and interaction effects plots. Effects plots are very visual and very informative. They are applicable to situations where there are only two factors. As we add factors, we must move to higher dimensions. For example, 3 factors would be visualized as a cube. 4 factors would be a series of cubes at each level of the 4 factors, and so on. Let's start with the most fundamental case. There are no main effects or interaction effects present for each factor. This chart shows a main effect for factor A, but no main effect for factor B. There is also no interaction. Here, we have a main effect for factor B, but no main effect for factor A. There is also no interaction effect. Now let's consider this plot. There is a main effect for factor A and factor B, but there is no interaction effect. For all 4 cases so far, note that the lines are parallel to each other. This is indicative of a non-interactional effect. Now let's consider this plot. There is a main effect for factor A, but there is not a main effect for factor B. We do, however, have an interaction effect. Here, there is no main effect for factor A, but there is a main effect for factor B. There is also an interaction effect. Here, we have 2 main effects for both factors and an interaction effect. This plot depicts the interaction between factors A and B. However, there are no main effects for either factor. As shown, as one factor increases, the other factor decreases by the same amount. We want to at least raise your awareness for the equivalent plot for 3 factors. As mentioned earlier, this can be best characterized as a cube. The vertices of the cube represent the levels of each factor. Again, it is assumed that each factor has only 2 levels. For a 3-factor design, there are 8 runs. Each run is 1 vertex of the cube. For higher order applications, visual plots become somewhat tedious since we operate in a 3-dimensional universe, and higher numbers of factors would require constructs outside the 3D space.